Now let's see Bayes theorem with an example. So I'll take the example and I'll try to explain you this entire concept instead of giving you the formula. Let's take the example first. So I'll be using the same examples which I have used for total probability. We'll revisit all the examples. Let us say there are three boxes, box A, box B, box C, and in box A assume that there are 2 red balls and 3 green balls, 1 red ball and 4 green balls, 3 red balls and 2 green balls. Okay, now there are various questions that can be asked on this example. One question that can be asked is, what is the probability of getting a? So again, the experiment is like this. We'll first choose a box randomly and then we'll pick a ball from that box, whatever box is chosen. Now one question we have solved is, what is the total probability of getting a red ball, right? So that is, what is the P of R, what is the total probability of getting a red ball. And now other question they can be asked is, what is the probability of getting a red ball given that A has been picked, which is nothing but 2 by 5, isn't it? And other question, okay, let me write it down better. So the reason why I'm emphasizing on this is, all the questions will exactly look like the same, but then the answers will be different, so you have to solve them differently. Now one question is, question number A is, what is the probability of getting a red ball given that A is chosen, right? So now in this question, not to answer it, you should be very careful while reading the question, and you should give importance to some words here. So here the important word is given that. So whenever given that is given, it means that they are talking about the conditional probability. So they are exactly talking about this probability of getting a red ball given that A has been chosen. So which is nothing but, what is the probability of getting a red ball from this box? So which we know is 2 by 5. This is what we have discussed in conditional probability, right? And the other kind of question they will ask is, just focus on the terminology. What is the probability of getting a red ball from bag A? These two questions look exactly similar right now, but then they are different. What is the probability of getting a red ball from bag A? Before this question, they will even give you the entire experiment. We are conducting a random experiment in which we will choose a bag and then pick a ball. Now what is the probability of getting a red ball from bag A? Which means they are actually talking about this event, probability of choosing the bag A and probability of getting a red ball from bag A, which is nothing but probability of choosing bag A into probability of choosing red ball given that bag A has been chosen. You might think that both are actually exactly sounding the same, but both are different. What is the probability of getting a red ball from bag A means bag A should be chosen first and then the red ball. But here if it is already given that already A has been chosen, then you have to continue with the remaining part. If already A has been chosen, now this one will become 1. Already A has been chosen, that is why you will get this. Got it? And now the other question is, what is the probability of getting a red ball? So before asking all these three questions, there will be the statement saying that we are conducting a random experiment where we'll choose a box and then a ball from it, right? So what is the probability of getting a red ball means they are asking about P of R, probability of getting a red ball, which is nothing but the total probability theorem, isn't it? Here there we are going to use total probability theorem. Got it? So now what does it mean? Now we know that total probability theorem P of R is probability of choosing bag A and then red ball from it plus probability of choosing bag B and red ball from it plus probability of choosing bag C and red ball from it. Got it? Since they are all mutually exclusive events, I am just adding them and I am not considering the intersection of these events because they are all mutually exclusive. A, B and C are mutually exclusive and therefore A intersection B, B intersection A intersection R, B intersection R and C intersection R are also mutually exclusive. Got it? Okay, now these are some of the questions that we can answer by whatever concepts we have learnt till now. Now let's answer a different question, very important question. This will combine all the concepts together. What is the conditional probability that bag A is chosen given that red ball is drawn? So this is very important question. Now what are all the things we know about this question? What are all the factors we know is, one is we know about, let me write here, what are all the factors we know, what are all the elements? We know that P of A is equal to P of B is equal to P of C. What is this? Probability of choosing a bag. This is equal to 1 by 3. And we know that P of R given A, which means probability of choosing red ball given that bag A has been chosen. We know this number. And then P of R given B, probability of choosing a red ball given that bag B has been chosen. P of R given C, probability of choosing a red ball given that bag C has been chosen. So we know all these six things, but then we don't know exactly what this question is asking is, what is the conditional probability that bag A is chosen given that red ball is drawn, which means they are asking about P of A given R. Got it? This is called reverse probability. Now what exactly they are asking is, an event has occurred, now we are supposed to find out the cause or the source, right? So we know that red ball has been drawn. Now what do you think about the source, or what is the chance that the source has been bag A, right? So that is what they are asking. It is really interesting. See now in order for the red ball to be chosen, there are actually three ways. Either red ball could be chosen from bag A, which means source could be bag A, or source could be bag B, or source could be bag C, isn't it? Now when there are three sources, now what is the probability that it would have been source A? That is what they are asking. Therefore P of probability that A being the source given that R is already known, all already has happened, is total number of sources, right? Which means like this, P of A intersection R, P of B intersection R plus P of C intersection R, P of A intersection R. Try to understand this one. Now they are asking, see, for the event R to occur, there are three sources, A, B and C, right? And now out of these three sources, what is the probability that the source would have been A? Now you take the source A and you divide with the total number of sources. Got it? Now I'll tell you why this is right. See this one. Now P of A given R is equal to, okay, let's expand it out. So we know that A and R are dependent, right? So what we know is P of A intersection R can be written as P of A into P of R given A divided by P of A into P of R given A plus P of B into P of R given B plus P of C into P of R given C. Now this entire formula, this is called as Bayes formula, right? And this is given by the scientist Bayes, mathematician Bayes, and so that is named after him, right? So Bayes formula says this. So we are going to use Bayes formula to find out this reverse probability. Why is it reverse probability? Is because we know these probabilities R given A, R given A, R given B, R given C, and now we are trying to find out the reverse of it, which means A given R. That is why it is called as reverse probability. Got it? So why is it right? See this. If you watch this entire denominator, if you look at this entire denominator, this one. See, in case of dependent events, I am doing like this. In case of independent events, it is going to change, right? In case of independent events, you are going to replace P of A into P of R, P of A into P of R, P of B into P of R, P of C into P of R. We are going to write like this. Now, this entire the sum of these three probabilities, these three terms, is actually probability of getting a red ball, right? Isn't it? So this is the total probability of P of R. So which means P of A given R is equal to P of A into P of R given A divided by P of R. Now you just multiply them, both of them, both the sides with P of R, then what do I get? It is equal to P of R into P of A given R is equal to P of A into P of R given A. Now we know that left hand side is equal to P of R intersection A, as well as right hand side is also equal to P of R intersection A. So that is why this formula is valid. This is the proof, isn't it? Check this. This is nothing but P of R intersection A. This is also nothing but P of A intersection R. Both are one and the same, right? Now let's see one other way of deriving the same fact. Let us say, how did we get this reverse probability? See, initially we know that we have divided this sample space into three events, isn't it? Initially we divided this sample space into three events. One is event A, which means picking up bag B, bag C, and then bag A, right? And then our required event of getting a red ball is actually spread across these three events. This is R, right? And whenever they said that, when they have declared that the event R has already happened, which means the red ball has already been drawn, then according to the conditional probability in this sample space, we have to change the probabilities, which means to all the elements which are present here in this region, we have to give the full probability, and to all the elements which are outside this, we have to make the probability 0, which means in effect the new sample space is actually present only in this region. The new sample space is this. See, old sample space, in case if they didn't talk anything about R, or if they didn't give that R has already happened, then the old sample space was this entire rectangular box. Now given that event R has happened, our new sample space has now changed, and our new sample space is going to be this one. I told you about conditional probability. So one way of evaluating conditional probability is change the probabilities. So whenever an event has occurred, or they said that some event has occurred, we have to reassign the probabilities for all the points. Now in this case, since they said that R has occurred, it means that nothing outside R is going to happen, right? Which means probabilities are all going to be zeros. Therefore our new sample space is going to be this, right? This is our new sample space, and in our new sample space we have three parts: first part, second part, and third part. Now they are asking what is the probability that this is the case, which means given that R has occurred, what is the probability that this would have been from bag A? Then how can you find out? You have to divide this part divided by total part. That is the total probability, right? Isn't it? So you have to take this part divided by total probability. This part is nothing but P of R intersection A divided by P of R intersection A plus P of R intersection B plus P of R intersection C. And we know that since they are dependent events, P of A intersection R is expanded like this, and P of A intersection B, A intersection R, B intersection R, and C intersection R are replaced like that. Got it? So likewise, you can know the causes of all the outcomes. So this Bayes theorem is mainly useful in finding out the source or the cause of an event. Similarly, they can even ask this question, that what is the conditional probability that bag B is chosen given that R has happened. So what is the main thing that you should see here? What are the main types of words that you have to catch in order to answer this question is, they'll give you this word, what is the conditional probability, right? And also they will give that given that. Then you should identify that it is a problem related to conditional probability. And then you have to find out whether it is direct conditional probability or reverse probability, which means are they asking the cause or they asking the event. Got it? Sometimes they will say what is the conditional probability that ball R is chosen given that bag A is chosen, something like that, which means it is probability of R given A. And sometimes they will not give you this word conditional, they will just ask what is the probability that bag A is chosen given that. Now again, given that is the keyword. Using that word given that, you can find out. Or other way of asking the question is, they will say that it is known that red ball has come out, then what is the probability that bag A is chosen? Again, whenever they said that it is known that means it is given that. So whenever the word is known that or given that or conditional probability, you should guess that the question has to be solved this way. Okay, so in case if the question is about what is the probability that bag B is chosen given that red ball has been drawn, then how can you solve it? It is nothing but probability of this one, B given R. This is what they are talking about. So it is nothing but probability of B intersection R, which is nothing but probability of B, right? So in order to understand this concept better, we'll take all the questions in which we solved about the total probability theorem and we'll solve them again for the Bayes theorem. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have, you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.